Okay, section 8.7 is complex numbers. This is the last section of chapter 8. I'm splitting it up into 2 days just because this is a brand new concept for a lot of you, and I just want to give you a few days to kind of process imaginary numbers and using this new letter I and things like that. Okay, so imaginary unit. So this is the number that's represented by this letter I. So a lot of us have actually heard of I and have heard the term complex numbers, but didn't actually know what I stood for. Okay, what I is a way for us to deal with negatives in a square root. Okay, we used to just say square root of negative 25, not real, and kind of move on. Okay, well, with imaginary numbers and complex numbers, we're dealing with those negatives inside of those square roots. Okay, I also want you to keep in mind, so I actually represents the square root of negative 1. Okay, and then I squared, so if I were to square the square root of negative 1, would equal negative 1, right? When you square a square root, the radical goes away and you're left with a number inside. Okay, an imaginary number is a number that can be expressed in the form bi, where b is a real number, and obviously it can't be 0 because then we wouldn't have an I. Okay, so for example, 6i would be an example of an imaginary number. Okay, so now we're dealing with the non-reals. So for example, it says write an imaginary number as a product of a real number and I. Okay, so before, again, if I saw the square root of negative 9, I would say non-real and kind of just go on with the rest of my homework. Okay, well here we're actually going to take care of that negative inside of that radical. So I am going to rewrite this as a product of negative 1 times 9. Okay, well I know, let me rewrite it like this actually. I know what the square root of negative 1 is, right? I know that that is now represented by I. Okay, my imaginary unit. And now that I've gotten rid of that negative 1, I know how to take the square root of 9, right? The square root of 9 is 3. So I have I and 3, and then usually, just like you write your coefficients with your variables, we write the number first and the I second, and then this is my final answer. Okay, so that is what the square root of negative 9 is equal to as an imaginary number. It is represented as 3i. Okay, so that means, if you could think backwards, that the equivalent of 6i would be the square root of negative 36, right? The square root of 36 is 6. The square root of negative 1 would be I. Okay, so let's go to number 2. So again, I'm going to break this up into the square root of negative 1 times the square root of 64. Well, I'm going to deal with that square root first because I like my number to come before my I. So we know the square root of 64 is 8. The square root of negative 1 we now know is represented by imaginary unit I. And that is my final answer. Okay, and number 3, I'm going to split this up into the square root of negative 1 times the square root of 18. Now I know the square root of negative 1 is going to be I, okay, but the square root of 18, we can't obviously take a perfect square from that, so I'm going to simplify like we know how to simplify, right? I'm going to break it up into 9 and 2. I'm going to take the square root of 9, that's 3. The root 2 is still left inside, and then I'm just going to tag I right next to it. So my final answer is 3 root 2, and then I. Okay, the I is staying outside of the radical. That does not go inside the radical with that 2. Okay, and then finally number 4, I have the square root of negative 1. If you already know right away, the square root of 48 obviously has to be simplified. I can't just take the square root of 48. You could break it up into the biggest perfect square that you know, or just smaller perfect squares, right? We know 4 and 12, or we could do 16 and 3. So I'm breaking up 48, this is the square root of 48, into 16 and 3. So I'm going to take the square root of 16, that's 4. I still have the root 3, And then now we know the square root of negative 1 is I, and then we are done. Okay. Adding and subtracting complex numbers. Well, before we get into actually adding and subtracting complex numbers, let's talk about what a complex number actually is. Okay, so that is a number that can be expressed in the form a plus bi. Okay, so here is my imaginary number. Okay, when we just have bi, we call that a pure imaginary number. Okay, and a and b obviously have to be real and b can't be 0. Okay, so an imaginary number is actually when a is equal to 0 plus my pure imaginary number. Okay, so an example of a complex number is here's my real number plus my imaginary. We have our complex number. Okay, so 6 plus 4i would be an example of that. So in example 1, this is just like combining like terms in a polynomial. So let's pretend that this was 7x and this was 19x. Those would be like terms, and I would combine those, and the x wouldn't change, right? It's the same thing with imaginary numbers. So I'm actually going to combine the negative 8 and the 5, and that's going to become negative 3. Let me do this in a different color. Then I'm going to combine the 7i and the negative 19i, and that's negative 12i, and then that's literally it. We're done. Okay, when we're adding, the parentheses actually don't mean anything. It's just kind of grouping the complex numbers and kind of separating them between the two. Okay, but you're literally just combining like terms, and then you're done. So in example 2, so now I'm subtracting my complex numbers. Okay, and in like any situation when I'm subtracting and I have parentheses, what do you think you do with that negative? You got to distribute it, right? So I'm going to distribute that negative in there. So I have negative 1 plus 13i minus 8 plus 3i. Okay, so I'm going to combine my like terms. So I have negative 1 and negative 8. That is negative 9. And then I have 13i and 3i. That's going to become 16i. There's my final answer. Okay, last one. I'm just going to rewrite this and kind of do it the long way, but you could make some shortcuts if you're kind of getting the hang of this. I'm going to distribute my negative, so I get positive 3 minus 2i, and I'm going to look for my like terms. So I have negative 3, positive 4, positive 3. Okay, these 3's are going to cancel out. I'm left with 4. Then I have negative 5i, negative 6i, and negative 2i. So negative 5 plus negative 6, that's negative 11, plus negative 2, that's negative 13i. Here is my final answer, my complex number for minus 13i. Okay, and then last section, so I'm keeping this kind of short. Like I said, I broke it up into 2 days. I just really want you to get used to the idea of using I right now. So before we get into multiplying complex numbers, again, I want to remind you that I squared is equal to negative 1 because I have the square root of negative 1. That is the same thing as I, and if I squared that, that would get rid of the radical, and I'm left with the number on the inside. Okay, so in example 1, I have 7i times 9i. So multiply the 7 and the 9 normally. Okay, so I get 63, and then the i's become I squared. Now this is just like if I had 7x times 9x, right? It would be 63, and that becomes x squared. I works the same way. It's just that I represents an actual number. Okay, so I'm going to replace I with what we know it's equal to, right? So 63, and this is the square root of negative 1 squared. Well, like we said, the square root of negative 1 squared, that gives rid of the square root, and I'm just left with a negative 1. So this is saying 63 times negative 1, which is equal to negative 63. Okay, and number 2, same thing. Okay, 10i times negative 3i, that becomes negative 30i squared. Well, we know now that I squared is just going to become negative 1, right? Because we're squaring the square root of negative 1. So this becomes negative 30 times negative 1, and then I get positive 30 as my final answer. Okay, if you're not okay with that idea, remember, if I'm squaring I, that is negative 1 squared, which is also equal to negative 1. Okay, that's where that negative 1 came from. Okay, number 3, I have 5i times this complex number 4 minus 7i. Okay, this looks a lot like a distributive property problem, which is exactly what we're going to do. We're going to distribute that 5i into the parentheses. So I'm going to do 5i times 4. Sorry, if you hear that jingling around, that's Millie, by the way. So if I pause a few times, that's because she's running around right now. So I'm going to do 5i times 4. So that's 20i. And then 5i times negative 7i. So that becomes negative 35i squared. So I can't do anything with this 20i. Okay, that's going to stay the same. I can't simplify that any further, but we know that I squared is negative 1. And so that becomes 20i plus, because now this is becoming positive 35, so plus 35, and there we go, that's my final answer. Okay, number 4, very similar, so I'm going to distribute this negative 2i inside of the parentheses. So negative 2i times 3, that's just negative 6i. And then negative 2i times negative 2i, that becomes positive 4i squared. But I know that I squared becomes negative 1, so 4 times negative 1. So the final answer is actually negative 6i minus 4. Okay, and then last example. Again, we're going to distribute, so 3i times 6, that's 18i. 3i times i, that becomes 3i squared. You could skip this step now if you're getting used to this idea. So 18i plus 3 times negative 1, because I squared is the same as negative 1. So my final answer is 18i minus 3. Okay? And that's it. So that's your intro to imaginary numbers and complex numbers. We're going to continue on with this multiplying. We're going to start foiling with some complex numbers. We're going to divide, and then we're going to kind of talk about when we get to higher powers with I.